This last video is going to talk about the unit circle, and it's kind of handy to have this as a reference sheet so that you can find the different ratios quickly. Also, just by doing this, it helps your mind remember where they need to go. So first, we're going to go around the unit circle, and we're going to fill in the radians that go with these degrees. So we're going to start at 0, which, of course, for radians is also 0. But then for 360, the radian is 2 pi. And then we've already talked about these first several. So 30 is pi over 6. 45 is pi over 4. And think about that's like 1/4 of, or it's half of the fourth, I guess is what you could say about this whole circle. And then pi over 3 is 60, and then 90 is pi over 2. Now, I'm going to go ahead and fill out the other two that we know, because we already know that 180 is pi, and that 3 pi over 2 is 270. So let's talk about the other numbers. So 120 is in with the same as 30, 60, 90. 30 more is 120. So that one's going to be 2 pi over 3. Think about it's twice 60. 120 is 60 times 2. And so twice of pi over 3 is 2 pi over 3. Then 135 is 3 times 45 degrees. 2 times 45 is 90. 3 times 45 is 135. So you're going to have 3 pi over 4. Now, the reason 90 is pi over 2 is because it was 2 pi over 4, and it got simplified to 1 pi over 4, or 2, because 2 over 4 is 1/2. Okay, for 150, we're going to continue that counting from 120. So 120, then you're going to multiply by 3 again. So you get 5 pi over 30. So think about how, over 6, not 30. I was already in my next step in my head of talking about 30 degrees. So 30 degrees kind of works like how 45 did with 90 and 135. So technically 60 is 2 pi over 6, which is 1/3. And then 90 is 3 pi over 6, which is 1/2. And 120 is 4 pi over 6, which is 2/3. And 150 is 5. It's the next thing. So we've got 4 and then 5 pi over 6, which I've already written, is not able to simplify like those other three were. So that's why it's 5 pi. It's the fifth one in that set, because 30, 60, 90 act as a set, and then the 45s act as another set. All right, then we get to 80 or 180, which for either one of these, you've got, it would be 4 pi over 4 if you're talking about the 45 ones. So that's obviously over just pi, because 4 over 4 is 1. For the other ones, it's the 6th in the 30s. So you would have 6 pi over 6. Again, that's just pi. So that makes remembering that a little bit easier, that you're counting as you do these, but also simplifying. So that's why they look like they're not in really an order, but they are, because they're being simplified as they go. The next one is, so this was 6 pi over 6 when you're counting by the 30s. And then the next one, 210, is the next 30. So that would be 7 pi over 6. Then I'm just going to keep going with the 30s. And then we'll come back to 225, which goes with the 45 vein. I probably should have done it that way from the start. So this would be 8 pi over 6, which simplifies to 4/3. So this one is actually 4 pi over 3. And then 270 would have been 9 over 6, which was, it simplifies to 3/2, so that's where that came from. And then 300 is the next one. So that one was, I've lost lost my place, 8, 9, 10. So we've got 10 pi over 6. Still can simplify. So 10 over 6 is 5/3. So we're going to simplify this. I wonder if I can just erase that part. Oh, that's a miracle. So it's 5 pi over 3. Then let's skip 315. It goes with the 45s. And then we've got 330. So this was 5 or 10. So then we've got 11 pi over 6. That does not simplify. And then when we get back to here, we have 12 pi over 6, which is 12 divided by 6 is 2 pi. So that's where all of those come from. And they do follow a nice pattern, especially if you understand how they are being simplified as you go. All right, for 225, it is going to be, think about, so this was times 2, times 3, times 4, times 5. So this one's going to be 5 pi over 4. Doesn't simplify. Then the next one would have been right here. That would have been 6 pi over 4. And 6 over 4 is 3 over 2. And so then we got to 315, which would be the 7th one. So 7 pi over 4 does not simplify, so it's just going to be that, 7 pi over 4. And then when you get back to here, you get 8 pi over 4, which is 2 pi. So they do all work out very nicely. So those radians, even though they are different and it's not something you're used to using, they're not hard if you follow that fraction reduction. Okay, so we're going to start again at 0. And we know from the table we did earlier, which feel free to look at that, is 1 over, or 1, 0. So the cosine was 1, the sine was 0. So actually, I'm going to go on down here and do these trig values so that we can remember that sine goes with y, cosine goes with x, and tangent goes with y over x. Just because that will help us as we're filling these out to remember cosine goes first. We always say sine, cosine. We really should say cosine, sine, because that would help with this tremendously. All right, so when we were doing that table, the cosine of 30 is square root of 3 over 2. The sine is 1/2. For 45, they were both square root of 2 over 2 because the 45, the x and the y are the same. For 60, it was the opposite of 30 because now those two numbers have interchanged if you make a 60 degree. Now you're talking about short side versus long side instead of long side versus short side. Then the 91 was 0, 1. Should make sense. It should be the opposite of 0 degrees, 90 degrees. And then for 120, you're going to use the same thing as its mate, so to speak. So 120 goes with 60. 135 goes with 45. 150 goes with 30. And think about that there. That should make sense based on what we did in the last video because 120 is 60 degrees from 80. 60 is 60 degrees from 0. So they are the same reference angle. So they're all going to be the same as far as the numbers go. So this is 1/2 and square root of 3 over 2. This is square root of 2 over 2, square root of 2 over 2. And then this one is square root of 3 over 2 and 1/2. What's different is that all of these x values, because we're going to the left, are negative. So you're going to put a negative on all of those, like so. Then the same thing is true for 180. It is going to be the same as the 0 value, except its x is negative. Same thing. All right. Then when we start doing the next one, they go in reverse order. So think about if you look at this as 210 matching 150 now. So 150 has a reference angle of 30, and so does 210 with 180. So that means they are going to have the same numbers. So they're going to have square root of 3 over 2 and 1/2. The next one is square root of 2 over 2 and square root of 2 over 2. Any of them that are related to 45, they're the same. And then 1/2 over square root of 3 over 2. And you can see up here that was the same as 120. Now that we're in the third quadrant, both the x and the y are negative. So I'm going to go back through and make all of these negative. And then 270 is, of course, the same as 90, only -1 because you went down. All right, and then for quadrant 4, you can look at them either way as they match up with the ones across 270, or they match up with the ones in the first quadrant, just like how we did the third quadrant. So I'm actually going to do it that way because that way is technically more correct. So for 300, we have 1/2 and square root of 3 over 2. Then we have for 315, square root of 2 over 2 and square root of 2 over 2. And then for 330, we have square root of 3 over 2 and 1/2. And then you have to think about, okay, which ones of these are negative? And it's only going to be the y values. So we're going to go back in and put those in because it's in the fourth quadrant. And then a nice little thing that this does is it kind of summarizes those signs in the quadrants for you for sine, cosine, and tangent. We've already talked about that in the previous video, but this is also nice to just have it on this as a reference. So we know, because we already talked about it, that they're all positive in quadrant 1. And then we know that, if we look at this, that the sine is positive in quadrant 2. Remember, sine is those y values. Is those? I'm not sure. So that's positive, but then the rest of the time y is negative. Cosine is negative on the left side because those coordinate with x. So x is negative in quadrant 2 and quadrant 3, but then positive in 4. And then tangent is negative in basically the vertical angles, so like across from each other, diagonally. That's the word I was looking for. So if everything's positive, in quadrant 1, so tangent's positive, and then everything's negative in quadrant 3, so tangent is positive because it's y over x. So it's positive in those two and then negative in the other two, because if you have a negative over a positive or a positive over the negative, then you're going to have a negative sign. So this is just a nice little reference for you guys. I am going to add one after all of us have talked about it in class that you can print. Actually, it may already be up there, that you can print separately. All right, that's all for the second lessons in Trig. So these should go along nicely with your Delta Math for Trig 2 assignment.